So the first question that you provided, feel free to speak about anything, and I'll try to focus first. So, what are the key technical challenges in implementing a learning healthcare system? Or maybe, so let's start with that. I think in your talk you mentioned quite a lot of technical terms. I mean, I am reasonably technical and I've heard most of the terms, but yeah, I found it, I can't fully follow the whole thing. So clearly, but I guess the whole point there is that we cannot underestimate the technical challenges required to create the vision that we want. So, what do you think are the key in your attempt to create a learning health system for clinical decision support for RCT? What have been the main?
Well, the two challenges which I was really trying to highlight were the first one that most people will talk about is heterogeneity. It's many different guises of all sorts. But actually underlying that, there's a tremendous loss of depth of meaning. So I think those are the two. The moment we have health record systems which are not designed primarily either to facilitate interoperation with other health record systems and other structures, or to capture more than a very minor amount of clinical information. It's just, it varies obviously, but the worst kind of thing are the kind of things they had in the US, where they do epidemiological studies based on billing records and it's represented. It's quite far removed from what it possibly gets.
So, well, clearly we've had clinical records for many years to try to help us guide clinical care, and if you read a clinical letter, most of you have probably read your own clinical letter or clinical letter, there's a lot of meaning in that narrative that your GP or the specialist. So if everything is there, what's stopping us from getting the meaning? If a human being could read it and get the meaning out, so it's...
Well, there are two approaches, and they're not mutually incompatible. But you can go the text mining route,
which is natural language processing.
Okay. So trying to impute meaning from what's actually written in structured language, which I think is potentially very beneficial, where you have a lot of existing rich text sources, and you can get a lot of extra information out from that. But you can't change what's being captured in the text format. It's a one-way street. Or you can go through the route of very intelligent dynamic templating systems, where the system knows what it is you're trying to collect and facilitates you in collecting it, which is what our decision support system is doing for the diagnostic things. And there you can enrich and clarify and structure the record. You can get a feedback cycle, you can get an early cycle down the record. So that's
just implicitly a third strategy, which is take the human being out of it and just not put it through the human world, just keep it in the computer to computer world. My blood pressure monitor talks to the system. It doesn't talk to somebody who interprets it, takes the one of three that they like, or averages drops the first one, averages the two, and I'm just saying sort of conceptually, I'm not advocating
for
this.
certain things you could do that. I think 30 years ago people thought you could do that for diagnosis. The patient would put that information in and the computer would give them the diagnosis. But I think we've moved very much now into a hypothesis that expert systems or decision support systems can augment human judgment and have to work in conjunction with the person.
I teach and research to some extent outside the health domain, and there's this kind of fascination with the so-called second economy. When you go to the airport, you put your credit card in the machine, and from there on, all the way to the meals and the baggage and the this and that, not a human being is touching anything, really. The last person who touches anything is the one who heaves your suitcase onto the thing, and thereafter it's just in the second economy, it's in the...
So what would be the difference between something like that and healthcare?
Well, good question. How long have we got? But and I'm not advocating it. I'm of your opinion that there is a difference, and we aren't just an airport trying to.
I guess it's the same set of attributes that healthcare has that makes that vision hard to accomplish. That also introduces these technical problems, which is, just healthcare is incredibly ad hoc. Just with NICE and with all the guidelines and with all of that, you realize that it relies on human being, the doctor, judgment a lot. And it's an agent-based economy.
Yeah.
So the only decision maker is a clinician, but the clinician himself or herself is acting on a set of incomplete, uncertain data, making use of the instruments based on his judgment, experience, I don't know, the position of the stars and the moon. It's an incredibly complicated thing. And it just, no matter how much you try to automate that, it's just the means and ends are quite strictly set in that context. And that makes it hard to automate things. And on top of that, my take on the technical feasibility, and again, it's going to be a bit of a narrow comment, probably because of my position. The machinery, although it's abstract stuff, the machinery you need to implement the kind of functionality that you're developing at the moment is extremely specialized. And it actually doesn't lend itself very well to mainstream technologies. Everybody in the EHR business would tell you the holy grail, the most important part of IP of all the companies in this business in EHR is the design of an EHR repository, for example.
When you mean repository, you mean
how you actually keep and serve and process data, and you just do not buy a few database books, install a few free databases, and go on with implementing these things. It just doesn't work that way. It's incredibly specialized, and there is just one component of the technical feasibility. You were absolutely right about what you were saying, because I've written 200 pages about this thing.
for your thesis.
Yeah, it's so don't worry.
So we'll tell you which one.
You won't hear all of it. You won't hear all of it. But one of the things I keep emphasizing over and over in the thesis, because I have the findings to support it, is the aim, the design goal, just the functionality that is reflected in a particular implementation of any EHR. 9 out of 10 times locks it into that use case only. So if you build something and there is a small GP system that's supposed to run a few thousand patients, and provide and respond to queries for that system by design evolves into a certain shape. And the second you try to hit it with queries across the population or try to use it to feed data into a Bayesian network of that sort, it just dies. So, just technical feasibility also is related to specialization of design into use cases. So, you can build a fantastic system that supports clinical care, and then you want to learn using that across the population, and you suddenly realize that's not as easy as you thought, because the design is very
not
specific.
designed for that interface.
Yeah, so that is a real challenge from a technical point of view, because all the assumptions of today about big data, about just leveraging large amounts of data, assumes that you'll be able to do it, that you'll be able to process that amount of data.
And it's ironic that Epic, the most successful EHR package in America at the moment, is built on MUMPS technology.
It is,
from,
exactly.
From
because,
the 1960s.
And MUMPS came out of a healthcare institution.
But it's 60 years old.
It is, and it still rocks, because its design isn't, that's exactly my point, because its design just somebody didn't say
Healthcare process.
what kind of relational database we can get our hands on and do
It
it.
was invented at that
They say they invented it, and it's incredibly simple. It's just a B+ tree structure with some indexing sitting on a disk with some transactional support. But
See, this way I don't understand science.
so it's basically it is very specific to the data structures you would save and manage in healthcare, and so it succeeds, it scales, it works.
Yeah.
That is by far, I think, one of the most important pieces.
So can I just take it back a little bit? So we want a learning healthcare system, let's say, across the National Health Service, which is made up of organizations, even though call it national, but it's actually multiple organizations there. And one organization probably will never have enough patients
in 4 countries.
In 4 countries, to learn. So what technical, so we tried the national program of IT, we tried to standardize everything, all the way from the structure of the data, doing maybe, I always scared to use words I don't fully understand, the whole ontology, every single clinical model, up to the tools to actually deliver healthcare. That was the national program of IT. It didn't work.
Anyway.
Maybe not.
Let's not open that conversation. I argue it did work up to a point,
Yeah,
and we are stupid to just damn it. And
no, it's not that. I mean, I'm just saying that it's not a learning healthcare system, that's what we wanted. So the question is, now going forward, you can't expect each individual organization to invest in something that everyone will hopefully benefit from. So how do we make things interoperable so that we can have this economy where we can freely exchange information that maintains the context and the meaning of the health record? What needs to happen?
Well,
in terms of
whatever needs to happen is a whole sequence of things needs to happen, and it's not one thing.
What are the, I appreciate that. So let's align that there's a political will and things. What technical, because since we're talking about technical challenges, what technical solutions or challenges is there in making that happen?
Well, it's...
My first technical challenge would be find a real problem today and solve it. And build momentum that way. Don't try and solve an imagined problem, 10 years out. Try and solve a problem today. And my example of not doing that would go back to the national program years. If you ask GPs what they wanted, informationally, say 10 years ago, they'd say discharge. We want discharge information. People walk in on a Monday morning, I'm just out of hospital, I don't know who, which hospital, where. Discharge was really what they wanted. They got choose and book instead. Yes. The one thing they didn't want. So I think the first technical challenge is find a problem that matters to people and start to solve it. And the danger of grand designs or choice agendas or whatever creative choose and book is avoid that. Find a real problem that people will really appreciate.
To manage that risk of building the wrong thing, maybe in the right way, and losing all the money and the opportunity.
Or as they say, is sometimes building the church for Easter.
That's why you need to think in very flexible, generic systems, or at least such an infrastructure that can accommodate.
But there you go. You're talking like a computer scientist there. But the more general, the better.
But this has been carried all the way. The idea of computer science, this idea has been carried all the way into standards. That's where I was.
But my solution would be that's not always, but you have to temper that with the other, which is a problem today, solved today.
No, absolutely. I was hoping.
And waiting to build the church for Easter, because when this big fancy system is all there and it's all generalizable,
it's not. Yeah, I don't think it's what we're talking about.
No,
but it can mutate into that if you're not careful. I think give you cases where it mutates from we want a generalizable thing, which means we've got to be able to do that, which means we've got to be able to do that, which we need this component.
There is an underlying simple way of achieving multiple objectives. And that's the challenge of computer science and informatics, to do that, which enables a problem solved today to create the scale to solve multiple problems.
Which is what I'm trying to achieve. I see it being perverted though.
Well, there needs to be a methodology that accompanies the technology. so that just you can actually design and build different systems following the same methodology and using the same set of components. That is, I mean, in many ways, one of the technical challenges. This was a very technical, very just the reason that made Ford an unbelievable success was its production model. And in many ways, solutions in healthcare IT are always hand-built. They don't come out of a production line. Therefore, they're very expensive to build and to maintain. And just so it comes, even though it's based on economic, just reason justification. It's still a technical problem to have a production line that can deliver reusable software platforms that can enable all the things we want to do. And I think, and I said this in the Pew's meeting, that takes significant leadership from the government in establishing those lines, because individual companies rarely try to change the way market works, and they deliver solutions in a way.
Are the technology or the standards or the frameworks to have that vision of a reusable piece of information? So reusable would be something I would think is like a standardized way of describing blood pressure, or a standardized way of describing medications, or allergies. Is it fair to say that the tools to create these standards exist?
I believe they do. Yeah, I believe they do. But they require a different approach, a lot of downstream changes in the way software is developed, and that needs some push for adoption. And there are many challenges. I mean, data size, just you can succeed with a mathematical model using 10,000 observations on your quite powerful modern laptop. And then you're going to look at like 50 million people with the same data. And if every time you have to rebuild the whole mechanics execution of it, then it becomes so expensive that it's not feasible.
So it's interesting. So one of the guys that ran EMIS, was a big GP record system. So he's resigned from EMIS, and he's, I don't know where he saw the headlines last week. So we're going to build a system that connect everything up together. And the reason he reached that conclusion was the very thing that you said, which that you can exchange information, but what happens at the moment exchanging information? You are constantly building a bespoke link between systems, and that's just become way too expensive. And what you are doing, I think, in your project is that you've got a central representation of the information, and you are building individual interface to that representation, which then that representation can have multiple use cases, something like that.
That's right.
Yeah. So that is a technical solution, a potential solution, and I guess one of the things is that representation, that model, that digital representation that you've created, who owns the intellectual property to it? Because there's a big problem. So at the moment, one of the biggest problems is not a technical challenge. It's more like, say, I own the intellectual property to that model. If you want to use it, you have to pay me a license fee.
I don't see that as a big problem in Europe. In USA, it would definitely be, just where the...
Well, I mean, we are an open source project.
Right.
We do not intend to profit from any IP
Of the models.
of the models.
Yeah.
The models are publicly available.
Yeah.
It doesn't get you away from the problem of maintaining, versioning, and
Of course
supporting the
not.
model.
You probably have to have a business, some sort of a business,
There is,
and
yes,
an
but the business
underlying
model
it
should
just to
not be
keep
focused around the value of the model. The model is simply a tool.
Yeah, it
The
should be a
business
service.
model is actually the functionality which is enabled by using the tool for those
Yeah.
connections.
Because that's your service oriented model.
That's
the
we have a
main-
service-oriented
yeah.
business model,
Yeah.
of which the core components, the software, the models, etc., are open source.
Okay. So the tools are free for anyone to use, but you need expertise to use the tools, and that's how you make. That's your
That's how you
business
help
model.
support them.
But as you say, it still doesn't get over the fact who maintains and versions
Yeah.
the model. So is that a role for the central government?
Well, what we're doing with the European projects is Eurorec, which will know, which Deepak Khan is president.
My second supervisor.
Yeah, have created an institute for innovation in healthcare, which is bringing together a variety of large-scale European projects which are currently competing for either FP7 or online. And we're all going to put our resources together and maintain this institute.
Okay. Is that something that is, sorry?
My sense is there's a role for government here, but holding the ring on this, I think I would be careful about.
Holding the ring, what do you mean?
On standards, and sort of becoming the sort of focal, not decision maker, but the decision hub for what's approved, what's not. I think
not standards. There are standards bodies.
Yeah,
so the standards will go through the standards bodies.
And there are open standards.
Yes.
Other proprietary standards. There's a whole sort of
the second level down.
These ecosystems of standard making, which are good and ones which are less good, sort of my opinion, and other people's opinions. And I think so trying to lump it onto government and say that's the role for government, I'm just a bit leery that that's the role for all of us.
Not the making,
to participate,
but encouraging their use.
But I think still that's the role for all of us.
And who's the government?
But all of us, I mean, no, but the industry has a place in the role, yeah. And I think the clinical interests too.
Eurorec represents the industry.
Yeah, well, exactly. That's why I'm saying it's better out of, and it's better in Europe, and it's better out of the government. If you mean the government here, that somehow the NHS should say always this, always that, always the other. The other, which they have. You know, some people think that's.
I would disagree with that because I don't believe in individual UK-based solutions. I think they have to come through international organisations.
And even, yeah.
If you would consider know-how part of technical feasibility, and I would say one of the, again, big problems, just like those EHR implementations, the know-how required to build health information systems is extremely specific, and we always end up, especially just when you're talking to a trust or a team in a trust, with an oversimplification of what you would need to build a system that follows standards and that has some.
But coming back to what you said, all the trust wants is a system that solves their problem there and then. They
maybe tomorrow. They may be a little bit tomorrow. More. But yes, I think preaching to them about the ideal system and the full mix of standards and interoperabilities and so on is in danger of disarming people's intent, and that would be my view. It's not everybody's view, but that would be my view, that we have to be a little bit more small scale in the way we build up our approach, and recognise exactly as you say that people in trusts can't handle everything. Yeah. They can't, and we can't tell them either that somehow we just have to go forward suboptimally every step of the way, but in time we make progress. Rather than imagine if we got all the bits together on day one, somehow turn the handle and it would all happen.
In a previous meeting I said, just working on the idea of evolution instead of a revolution, because that scares everybody, especially in a trust, and thinking that they'll have to change things overnight. That's, I mean, a few types of pushback is so characteristic when you're trying to improve things. Well, one of them is we don't need that, we can do it in-house from the trust teams all the time. And the very polite answer is, trust us, you cannot. If you let us, we can work with you and show you, but it's not something, going back to that specialization, it's not something you can do on your own. The other one is, we invested all this money into these systems, so do you expect us to throw everything and just cover the cost of training and all that transition, what happens to legacy data? So just then you have to say no. We can do it gradually. So that all of that, I guess, still comes to just to the assumption that there has to be a good understanding.
I have to draw this to close, but just coming back to the question about the key technical challenges. What I'm hearing is that there aren't that many technical challenges. There might be an awareness of the technical solutions, or there might be an ignorance of the need for the actual technical things to support it. So it's more an issue of maybe the lack of skill, lack of awareness in key decision makers?
I think the way I would put it is there are potential technical solutions.
Yeah,
Okay.
that's a better way.
Yeah, but the potential carries a lot of work around scalability, applicability, detail and things to do. So it's not something you can take off the shelf.
Hi everyone.
Yeah.
Probably got another 5 or 6 minutes.
Okay, thanks. Have you, just out of curiosity, in your project, did you actually have any technical blocks? Did you have a meeting where someone from the technical team said, sorry, because we can't do what you're asking us to do?
Oh, God, continually, yes.
Which is...
Yeah, it's, the vision has been there all the way throughout, but actually doing it on the ground is really, really difficult. And actually what you have is a sort of, a kind of variable mixture of slightly different technologies applied in association with different things. The principle sounds very simple, but when you actually get it to on the ground, how is it implemented with that DHL? You'll find you can't do it through the API through that, so you have to actually translate the XML into a SQL query, you have to run a SQL query, and the logic can't be represented in the XML, you have to make sure the logic is in the SQL query, and it just gets a lot more complicated, so it's very much something that's in development.
That's precisely my finding.
Yeah.
So I made a decision and David Ingram said, okay, go with it, which was crazy. I said, I'm going to implement the open air persistence layer to observe if it ticks or not under these circumstances, which on paper would look perfect, but the second you try to make it work, millions of things just, and I guess not being able to share that know-how or not having access to that very critical know-how overall is also a problem.
Critical know-how of what?
Of actually implementing EHR systems.
So you need to get together
yeah.
somebody who really understands ontologies, you need to get somebody who understands databases and can write SQL code in their sleep, with somebody who understands ADL and archetypes with a clinical team.
Exactly.
And you need to sit them down together before you can do anything in this area.
And their findings, what they found out, that's pure gold. But there is the kind of information that really isn't successfully disseminated. Happens, how many projects I heard, I don't know, focusing on similar things. Yeah. But don't get me wrong, I'm not saying this for your project, but almost all, in all cases, even though it's, as far as I know, funded by taxpayers' money in Europe, you do not get access to outcomes of these type of projects and see in detail what worked and what didn't work. Yeah. And so there's a serious connectivity problem between the outcomes of very good research and actual implementation teams who may take it to the field.
Well, they take things that are well implemented, like, for example, Transmart. Is anyone familiar with Transmart? Transmart is a translation research platform based around linking clinical data with omics data, so you can do querying and things. So it supports simple data manipulations.
What's omics
data? Genetic
okay,
and it takes the I2B2 data model, which is star data structure, clinical event, person, place, time, and sort of diagnosis or other event type, and a whole series of these things. So you put your data into this data structure, and then you can run queries on it, you can split it, you can explore it, export some statistics and things. That's a Transmart platform. There are probably around 200 or 300 institutions there around the world who are using Transmart to do things. Some very successfully because they've got the right skill mix and the right people to create the right pipelines to manipulate and map and get the data into this thing and make it available and make it work. There are other people who come to it and think it's an off-the-shelf solution, set it up and say it doesn't work. And it's exactly that gap.
Yeah.
It's what, in the sort of digital business world, you talk about as capabilities.
Yeah.
Organizations, before they do sort of get to use the technology, they have to build the capabilities, and those teams, those multi-functional, multidisciplinary teams.
There's an ugly aspect of big data. Everybody thinks
big data is going to solve all the problems.
Not me.
It's exactly that problem that you have to compute first.
So the sort of the capability in the human resource. In the sense of answering the question of technical feasibility, well, the feasibility is limited by the quality of your multidisciplinary team.
Multidisciplinary being the really key thing there.
And the depth of their knowledge.
So I guess we mainly talked about interoperability of political information. We didn't quite go into things like security. Do we have the technologies to manage the proper access to information and things? But we can use that. We actually cover a little bit of potential solutions. But what I hear is that there are technical solutions to the problems, but there needs to be, I guess, a bit of knowledge to put it in place, and there needs to be people that even to know how to apply these technical solutions to make something actually really happen.
And when you do it, you have to share it, because it's a very expensive experiment. Just like the large hydrogen collider. Imagine spending all that money and just not mentioning the findings. By the way, that is, I think, a big problem.